All right, guys, so what we're going to do today is we're going to kind of break up all of the vector component addition stuff for a couple of days. And we're going to work on this map activity that still involves vectors, but also involves some v equals d over t and kind of simple stuff like that. Okay, so we're going to work on that in groups. I would say your groups should be at a bare minimum 2 people. And at the maximum 4 people. Beyond that, there's either too much or not enough work, okay, for everybody to go around. All right. So, how many people have ever used a topographical map before? Yeah, it's not surprising. You guys all just pull out your phone and Google Maps tells you exactly where you are, okay, and all that stuff. So you've probably never used a topographical map, but let me tell you that back in the old days when I had to walk uphill both ways to school and snow up to my hips, okay, we used to use these things called maps. They were big folding pieces of paper and they had pictures of, well, what the ground was supposed to look like, but it wasn't actually a satellite view like you guys have. And you would have to figure out your way around. And they would have all these squiggly lines on them. Okay? And some of the squiggly lines were rivers and roads, and some of the squiggly lines were contour lines that told us how steep things were, okay? Or whether if something was a valley or a cliff or a hill, and we had to interpret things from that. And then the real challenge was you had to try and fold it back up without, and that was never, you just crumpled it and threw it away because you couldn't ever fold the thing back up. Okay? So, a topographical map looks like this. All right, so this particular topographical map is of a section of Jasper National Park near Moline Lake. Okay? What you are going to have to do with your group is find routes from the starting point to 1, from 1 to 2, from 2 to 3, 3 to 4, and 4 over to 5. Okay, that's going to be your trip, okay, is getting to all of those points. Each one of those is going to represent a day. So from start to 1 will be day 1, okay, and from 1 to 2 will be day 2. You're going to have to record a few things. Okay? As you're going along and looking at your routes, you're going to have to record your total distance traveled. You're going to measure it and record it. You're going to measure and record your total displacement, magnitude, and direction. You are going to calculate your total time spent walking. You are going to calculate your average speed and average velocity for each day and over the entire trip. That sounds like a lot, but it really doesn't take that long, and it's obviously not super complex either. Okay? Now, when you're traveling in the mountains, there are some rules. Okay, and they're not so much my rules, they're just like the rules of walking around in the mountains. Okay? The first rule is that if you're on a trail, you can walk faster than if you're off a trail. That seems to make sense, right? I mean, if there's no trail, you're blazing a trail. And sometimes that can be very difficult, especially if there's thick undergrowth or something like that. Okay, so eventually. Okay, so the first rule, is altitude affects speed. Okay, the bushwhacker rule is the second rule. Okay, altitude affects speed. So on the trail below the tree line, on that map and the map that you are going to get, okay, below the tree line is green because you're in the trees. Above the tree line is white. Okay, if you don't know what I mean by the tree line, every day when you look over and see the mountains, which you can't see today, okay, you can see, where there's a line on the mountains, okay? And above that line it's gray, and below that line it's kind of green, okay? That's because at a certain altitude, trees don't grow anymore, okay? Hence, tree line, all right? So below the tree line, if you are on a trail, you can walk at 1.5 meters per second, okay? Above the tree line, on the trail, you can only walk at 1.2 meters per second because, well, there's less oxygen up there and you get tired faster, so you can't walk as fast. Make sense? Okay. The second rule is the bushwhacker rule. Okay? If you are off trail below the tree line, the trees are going to get in your way and you are going to slow down to 0.75 meters per second. If you are above the tree line, off trail, you can walk at 1 meter per second. Does that contradict the first rule? You're actually walking faster at a higher altitude. But that's okay because there aren't any trees in your way anymore. You're above the tree line, so being off the trail doesn't matter nearly as much, okay, when there's not a bunch of stuff to walk around. Okay, so these are speeds that you just have to refer back to when you're planning your route, which I'm going to show you in a minute. The third rule is the silly salmon rule. Because you are not a fish, crossing a stream or river is an event. Okay, it's not something that you take lightly. If you're on a trail, what will be there? If you're on a trail and you come up to a river, a bridge. So you don't have to worry about crossing a stream if you're on a trail. You'll just walk across the bridge and you'll be fine. Okay? But if you're off trail, and believe me, I set it up so you'll have to do this, okay? You have to be quite a bit more careful. So you'll have to add 15 minutes to your total time to the day for every time you cross a stream off trail. Okay? Because you want to pack everything up, make sure it's all watertight. Maybe you take off your boots and put on your water shoes. Okay? You have to pick your way across the river carefully so you don't fall down and drown. Okay? So yeah, it's an ordeal. It adds 15 minutes to the day. Okay? Because they got to throw some stuff your way, otherwise this is way too easy. Okay? So those are the 3 rules. All right, so the second part is to practice your kinematics, and as I said, you are going to have to tell me the following things. The total distance traveled, you're going to measure that. Okay? The total displacement, measure / calculate, because you got to get the vector in there. Average speed, average velocity, and total time for the day, because you need the total time to calculate these 2 things. Okay, so here's what you and your group are going to do. Okay, and I'll kind of help you out with day 1, and I'll leave it on here. Okay. On the map, from start to the first cabin, there's a dotted line. What do you suppose that dotted line represents? It represents trail. Okay? Is that the logical way to go from the start to 1? Yeah. If you can walk the whole day on the trail, it's going to make your life easier to walk and to calculate, because you'll only have 1 speed that you'll walk at. And there'll be bridges every time you cross the river, and everything will be hunky-dory. Okay? So, you would then follow a path that goes something like this. Okay? How am I going to measure that? I can't put a ruler on that. It's all crooked. Any ideas how you measure something that's crooked? Take something flexible. This isn't as flexible as I imagined it to be when I grabbed it. Okay? And you make it take the shape of your trail. And then, when you have it take the shape of your trail, you pull it straight and measure it. Now you know how far it is. See, old tech, okay? It's old school, really old school. Okay? Except in old school we wouldn't have had one of these. We'd used a shoelace probably or something like that. Okay? So that's how you'll measure those crooked lines that represent your distance. Right? Then you'll know your distance. Measured, okay? Here's the other thing you need to know. The scale on this map is 1 to 50,000. That means 1 centimeter on the map represents 500 meters in reality. Okay? So whatever you get in centimeters, it'll be that times 500, and it'll be in meters. Okay? Everybody with me there? Okay. So that'll be the distance. I'll have that, it'll be measured. Okay? Then, I'm going to need to draw a line that represents my displacement. Okay, so I'm just going to draw a blue line so it matches here. Okay, that's a line from start to 1, from start to finish for that day. Does it represent my displacement? Okay, so could I measure it and know what my displacement is in meters? Okay, what else do I need about displacement?
Direction.
Direction. Now, fortunately for you, on a map, there are grid lines that go north and south and east and west. So what you'll want to do is draw some vector components. Okay, a line that's parallel to the north-south ones that'll represent your north component, and one that's parallel to your east-west lines that represents your east or west component. Okay, can you use those to get your angle? Okay, so for each day, I should see that on your map. Your chosen route, an arrow representing your displacement with a triangle representing your vector components, okay? And you might want to write on there how long all those things are in meters. Okay, that's what I want to see for each day. That's just the distance and the displacements. That doesn't take very long. The next thing you need to do is figure out how long you're going to be on the trail for. Now, since I walked that whole day on the trail below the tree line, do I know how fast I walked? Yeah, because rule number 1, altitude affects speed, told me that I can walk at 1.5 meters per second on the trail below the tree line. So if I know that I walked 1.5 meters per second and I've measured how long this crooked line is, I should be able to calculate how long it took me to walk. Agreed? Okay. Once I have that time, will I also be able to calculate my average speed for the day, which for day 1 is going to be 1.5, spoiler alert, because you only walk on the trail below the tree line, okay? And my average velocity, which would be my total displacement divided by my total time, okay? That's what you need. You'll have your time, you'll have your distance, your displacement, your velocity, and your speed. You need those things for each day. Now, here's where it gets a little bit more involved. Day 1 is easy, that's why I drew it on there, okay? But on day 2, I cut off the map so that you couldn't follow the trail all the way from 1 to 2, because I'm that guy, okay? It makes your life difficult, right? So you are gonna have to go off trail to get from 1 to 2 below the tree line. So I would suggest you might want to use different colors to represent the different speeds at which you can walk. Okay? Off trail, on trail, below the tree line, above the tree line. And then you can measure them as separate parts so that you can calculate how long that part took, how long that part took, etc. Making sense? Okay, so that's what we're going to be doing today and tomorrow, right? You need to split up the work. And you need to find out from your group members if any of them are not going to be here tomorrow. Okay? If that's the case, don't give them the map to take home with you. Okay? That'll end badly. Right? And also, make sure you give them a job. Maybe you want them to do all the calculating and measuring for day 4. Okay? That way they can do that, and when they come back, they can give you their work, and you'll have all the days. Or maybe you want them to calculate all the distances or all the displacements, whatever. You decide how you want to break up the work. Everybody's got to have something to do. Okay? Don't let somebody ride the coattails of the rest of the group. Okay? Make sure everybody's got a job. At the end of the day, everybody needs to take a picture of the map in case the person holding the map doesn't show up tomorrow. Okay? Maybe they're sick, whatever. Okay? But you'd be pretty screwed if you don't have a picture of the map to work from tomorrow in class. You'll be starting over again. And I don't want that for you. Everybody takes a picture of their group's map at the end of the day. Okay? All right, questions from you guys? Okay, so each group needs to come up front here to my desk, and you will get, for your group, one assignment sheet. You'll write all your names on there. It has all the instructions I just went through on it. And a map. Now the map contains 3 parts. You will have to connect them. In connecting them, you will want to cut off the little white pieces of trim, because no matter what you do, you're always going to have little borders when you photocopy things. Okay, so you'll want to cut those off so that you can match them up, and it's going to be pretty clear which one goes where, because there's words that go across, and if they're not spelt right, they're not going to match up. Okay? They're also not going to match up perfectly, but make sure they match up so as many of those lines go together as possible when you tape it together. Okay, now just so you know, it's a little hard to see some of the numbers Okay, like for example, number 3 happened to end up right on the seam of the map. You can see it there, but it's right at the very edge. Okay, so between these two sheets, number 3 is right on the edge. Okay, so make sure you see it there. The other thing to watch out for, because some people got confused with this, down in this corner, I have like a D4 and a D3 labeled. Ignore that. That's from a backpacking trip I did before you were born. Okay, hence a paper map. Okay, so don't just ignore that part. Okay. The other thing you need to know: the red line is a road. I don't know why you would need to walk on it. Really doesn't help you get anywhere, but should you decide for some reason that you wanted to walk along that road, the road is like a path. Okay, same rules apply. It's below the tree line, it's 1.5 meters per second. Last thing you need to know. On here, when you're reading a topographical map and deciding your route, these lines here, all these little squiggly lines, those are your contour lines. They tell you the altitude change. The closer together they get, the steeper it is. So this is a hill, but would be totally walkable. I would say that this is a cliff. Okay, the lines are right on top of each other. So if you're planning on drawing a line about where you're going to walk and it crosses a spot where the lines are right on top of each other, that will be the end of your trip. Okay, because you'll fall, and I don't want you to fall. Okay, so watch out for cliffs. Okay, your route has to make sense, because I had somebody who's like, well, I'm so smart, I'm just going to draw straight lines. You can't walk in a straight line from any one of these to the other. Okay, I made sure. Okay, all right, questions from you guys? All right, so when you're making up your groups, please make sure everybody gets included, okay? And send up a rep from the group to get the assignment sheet and the map sheets. I will also put the tape and stuff up here, and you can access, I've got 2 rolls of it, so maybe just take a few pieces back to your desk so that you can tape those together. I also have a few pairs of scissors here. People want to trim off the edges of those maps. Okay, so send up somebody from each group, and I'll get you the stuff here. Okay, guys, just so you know, this will be due. You're so lucky it's a leap year. You gained an extra day. It's due on the 29th of February. Any other year, it would have been the 28th. So, just so you kind of know what I'm looking for here, okay? I'm going to honestly want to see your map with all the lines and triangles and all that stuff drawn on it. I'm also going to want to see your work, okay? So any calculations and things like that that you do, I'm going to want to have that included, okay? But what I'm really looking for, okay, is on day 1, average velocity, average or total displacement, total distance, average speed, total time, okay? And I want that for each and every day. So you're going to put those things on a sheet somewhere for each and every day and for the whole trip as well. Okay? Now, for things like time and distance that are scalar, that's pretty easy. You're just going to add up all the days. Okay? But, guys, hey, but for average velocity, you still got to draw your line and do all of that stuff. Okay? Here's what people miss on this assignment every time. They forget, for some reason, on an activity labeled vector activity, to put vectors on the vector quantity answers. Okay? Average velocity needs a vector on it. Displacement needs a vector on it. Hey, here's a good news thing. Are they going to be the same vector? Yeah. Yeah. So it's not like it's extra calculating. Just remember to put it on both. Okay? You'd be surprised how many groups forget that, and then they lose a mark for every single velocity on the whole assignment. Okay? Because they've forgotten to put a vector on a vector quantity. Little things, but they're important. Right? So that give you a better idea what I'm looking for? Okay? The whole map and something with this on. It's probably going to be several sheets, but